Let's work on some trig problems here. The first one asks you to solve sine of 2x equals cosine of x from 0 to 2 pi. So with that in mind, here we go. Sine of 2x. So what does sine of 2x equal? You have to know your double angle identities. Sine of 2a is equal to 2 sine a cosine a. So that means that sine of 2x is going to be 2 sine x times cosine x equals cosine x. You can't just divide both sides. Rather, you have to subtract cosine over, set equal to 0, and then do a greatest common factor. Factor out cosine of x. From here, you set each factor equal to 0. Where does cosine equal to 0? And then where does 2 sine x minus 1 equal 0, which means where does sine of x equal 1/2? Because you add the 1 and divide by 2. So where does cosine equal 0 at? So let's go back. Cosine we know equals 0 at pi over 2, but we also have to know that, if it's 0 pi over 2, because cosine relates to an x-coordinate on the unit circle, and sine relates to the y-coordinate. So it's going to be at pi over 2 and also at 3 pi over 2. Where does sine equal 1/2 at? Well, at pi over 6, but that's not the only answer here, okay? So let's see. Let's go back. So we know it's going to be at pi over 6, but we know sine is positive in quadrant 1 and quadrant 2. So it's going to be pi over 6 and 5 pi over 6, because that's the two quadrants where sine is positive. The reference angle is pi over 6, and so sine of pi over 6 and sine of 5 pi over 6 will both give you an answer of 1/2. And those are the 4 answers for this question. If you're asked to find where cosine is greater than cotangent, well, first of all, get everything to one side. You can subtract over cotangent. Cotangent is cosine over sine. That's a quotient identity. We need a common denominator, so you multiply by sine over sine. So now I've got sine x, cosine x, minus cosine x, all over sine of x is greater than 0. Factor out a cosine of x. Now you have cosine of x, sine of x minus 1 over sine of x is greater than 0. Woo! Okay. This is a lot. Let's bring it on over. You can go, no, you go bye-bye, and you stay with me. Okay? See that? Do that. Let's do this, and this, and this, and here we go. Okay. Where does cosine equal 0 at? We got each factor here. And guess what? We have an inequality, and we have more than one x here. So we're going to have to set the number line. So where does cosine equal 0 at? We're going from 0 to 2 pi. Well, we already mentioned cosine equals 0 at pi over 2 and at 3 pi over 2. Where does sine equal 0 at? Well, sine equals 0 at, let's see, at 0 radians, but it also over here pi radians, because that's where the y-coordinates can equal 0 as well. So that's going to be at 0 and pi. And then this last factor, where does sine equal 1 at? Well, sine equals 1 at pi over 2, which is already right there on the number line. So here we go. So now what do? Well, we have to plug in numbers before and after, because everything is an open circle, and we need to figure out what interval this is going to hold true, or intervals. So what's between 0 and pi over 2? Well, if you notice, these are all the quadrants. So I'd probably just pick something like pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. I'm literally just looking at this and going, okay, I just want something between. Again, 0 and pi over 2, pi over 2 and pi and 3 pi over 2, 3 pi over 2, and 2 pi. So I'm just picking all of those, because I know it's going to give me square root of 2's over 2's all around. Now, square root of 2 over 2. Well, we know that answer is less than 1. Let's keep that in mind. Here we go. We're going to plug in pi over 4. Cosine of pi over 4 is square root of 2 over 2, which is positive. On the bottom, sine of pi over 4 is square root of 2 over 2, which is positive. Square root of 2 over 2 minus 1 is going to be negative, because square root of 2 over 2 is less than 1. Square root of 2 is about 1.4 divided by 2 is 0.7. Fun fact you might want to know. In total, it gives you a negative. Now let's do 3 pi over 4. Cosine of 3 pi over 4. Well, 3 pi over 4 is in quadrant 2, where sine is positive and cosine is negative. So again, cosine is negative and sine is positive in quadrant 2. And again, sine of 3 pi over 4 will be square root of 2 over 2 minus 1 will be negative. Negative, negative, positive will give you a positive. 5 pi over 4 is in quadrant 3, where tangent is positive, sine and cosine are negative. So that'll be negative, negative, and then negative square root of 2 over 2 minus 1, well, that's going to be negative. 3 negatives, multiply, divided gives you a no. Gives you a negative. I want to see if you're paying attention. Lastly, 7 pi over 4 is in quadrant 4, where cosine is positive, the rest are negative. So cosine of 7 pi over 4 is positive, sine of 7 pi over 4 is negative, and again, negative minus 1 will also give you a negative, and that gives you a positive. Ultimately, we wanted greater than 0, so we wanted every positive interval, which means the answer here is going to be pi over 2 to pi, union 3 pi over 2 to 2 pi. That's the effort that's needed for this type of question. I know I can make this look a little easy sometimes, but this takes practice and takes patience to solve one of these. There's not a quick way. You've got to take your time. One more. Let's say you're not solving. It just says if tangent of x equals 2, find cosine of 2x. So it's basically saying given one trig function, find another. Okay, well, cosine of 2x, that's a double angle formula. So cosine of 2x is going to equal, let's see, 2 cosine squared x minus 1. That's one of the 3 double angle identities for cosine that you need to know. Now, tangent is equal to 2 over 1. And tangent, if you recall, SOHCAHTOA is opposite over adjacent. And we know that opposite squared plus adjacent squared is equal to the hypotenuse squared in a right triangle. So that's 2 squared plus 1 squared equals the hypotenuse squared. So the hypotenuse is going to be the square root of 5. And we can't figure out if it's positive or negative here, but we don't need to because guess what? We're going to go ahead and take cosine, which is adjacent over hypotenuse, and square it. So regardless if it was positive or negative, it wouldn't even matter because we're going to square it. 1 squared is 1, square root of 5 squared is 5, 2/5 minus 1. Get your common denominator, and you will get a final answer of negative 3/5. That's how you apply trigonometry with problems, whether it be just a ratio of different sides like example 3, or equations or inequalities like example 2 or example 1.